All right, so checkpoint 8. Let's go through all these questions. This is the first question here. I believe, Natalie, this is yours. So I know you just skipped all of them, which is fine. It's talking about Richard, and he stains 11.4 square foot tabletop using 19 ounces of stain. He wants to determine the largest table size he can cover with the remaining 29 ounces left in the can. So let's see, he does the following calculations where T is the size of the table in square feet and S is the amount of stain in ounces. Let's see, so here's his equation, and he concludes that the remaining stain will cover 46.4 square foot of the tabletop. Part A wants to know, did Richard calculate the size of the tabletop correctly? Just pull this over here. All right. Okay, so let's try and figure out where Richard got this 1.6 from. Remember, when we're writing our equations, when we have y equals k times x, k is going to be our unit rate, which means let's figure out the unit rate for this problem and see if it is 1.6. So it says that he can stain 11.4 square feet of his table using 19 ounces of stain. So let's see. He has 11.4 ounces of stain for every, or he can paint, this is how many he can paint over 19 ounces total. Let's pull open Desmos. So 11.4 over 19. Let's see, so I get 0.6. Let's try, I want to try it flipping it the other way just to see. So this way he gets this 1.6. So this is where he made his mistake, okay? So your bottom, whenever you're creating a ratio, should be your total, or it should kind of be like your overall, like this is how much I have. So since the problem says that he can stain 11.4 square feet using 19 ounces of stain, the 19 ounces is essentially his total, which is why the 19 ounces should go on the bottom here. So for part A, no, Richard's calculation is not correct, and it's just because this first number in his equation is incorrect. Let's see. So no, Richard's calculation is incorrect. He set up the equation in line 1 incorrectly. Okay, so I'm going to erase this and then rewrite our correct equation. So this should be T equals 0.6 S. Okay. So then for part B1, we want to know what size tabletop will the remaining stain cover. So he has 29 ounces of stain left. So the 29 I'm still going to insert here for my S. So I'd have T equals 0.6 times 29. And let's multiply that here. So 0.6 times 29. Let's see. Chelsea tells me it's 17.4. Perfect. It's also what I got. So for part B, the remaining stain will cover a 17.4 square foot tabletop. That's it. Questions on that one, or are we okay? All right, that's it. Next problem, number 2, second one. Is it loading? I might have to refresh it. Let me refresh it really quick. All right, here we go. Okay. All right, so let's see. This question says that an archer stands 60 meters from a target. She launches an arrow and it lands 3 centimeters from the bullseye. The archer changes her position to 40 meters from the target and her next arrow lands 2 centimeters from the bullseye. She changes her position to 20 meters and her next arrow lands 1 centimeter from the bullseye. Which of the following points describes the archers stand at 40 meters? Okay. So let's see. When she is 60 meters from her target, it's 3 centimeters away. So when she is standing 40 meters from her target, how many centimeters is she away from the bullseye? So Chelsea says 40,2. And Natalie agrees. So you guys are correct, because if I were to read this in the order that it's written, I would have 40 meters from the target lands the next 2 arrows. So the 40,2 would be correct here. So 40 represents our meters, and then 2 represents our centimeters from the target. That's it. We good to go to the next one? All right. Let's see, a ski lodge sells 50 additional ski passes for every 3/4 of an inch of snow that falls overnight. Which equation describes the relationship P, the number of ski passes sold, and S, the inches of snowfall? Okay, let's see. Well, how many ski passes do they sell for 3/4 of an inch of snow? So how many ski passes can they sell? 50, right? So for every 50 ski passes, I can sell 3/4 of, sorry, I sell 50 ski passes for every 3/4 of an inch of snow. So what I'm going to do is, remember when we're writing our equations and y equals k times x, k is our unit rate, which means we need to have a 1 on the bottom here. So I need this to equal something over 1. So to do that, we divide by 3/4. So I'm going to divide 50 by 3/4, and I'm going to type that into Desmos. So 50 divided by 3/4. 50 divided by 3/4. And it tells me that it is 66.6 repeating. And if you don't know 6 repeating as a decimal, if you wanted to change that to a fraction, be 2/3. So I'd have 66 and 2/3. If you change it this way, you could divide the 3 into 200 as well to get the mixed number. So when I look at these answer choices, I have 2 different equations that have the 66 and 2/3, right? So now we are trying to look and see which one of these equations has our variables in the right spot. Remember that the variable by itself is kind of like the total, right? So if I want to know how many ski passes, which is P, I can sell, it's based off of how many inches of snow I get, right? So I want to pick this first equation here like Chelsea has, where it's P equals 66 and 2/3 times S. So the one where P is by itself. So P equals 66 and 2/3 times S. A lot of these equations is just reading the problem carefully. That's it. Next one. If it loads, it's not loading again. Interesting. Oh, there it goes. Okay. So out of 32 students in Mr. Martin's class, 18 are boys. If this ratio is proportional to the ratio of students in the school and the number of boys in the school, which of the following proportions would best be used to find the number of students in the school? It is given that 486 boys are in the school. Okay. So what is the first ratio that I can make based off of this first sentence here? So based off this first sentence, I can write a ratio. See, Chelsea says 32 over 18. I agree. So whenever you're in doubt, just write your ratio in the order you read it. So 32 comes first. I'm going to put 32 on top. 18 comes second. I'm going to put 18 on bottom. So 32 is the number of students, and 18 is the number of boys. So it tells me that there are 460 boys in the school. So if my units need to stay the same here, do I want to put that number on top where students is, or do I want to put that number on the bottom where boys is? It should go on the bottom, right? Because since boys is on the bottom here, boys is going to be on the bottom here. And since I don't know what number goes up here, what should I put here? Since I don't know what number goes on top. A variable, right? S or X. I'm going to use S because in this problem, it has S. All right. So now all we have to do is pick the proportion that looks identical to this one. So 32 over 18 is equal to S over 468. So make sure that you double check it to make sure that your numbers are in the right order here. And then let me know when you're ready to go on to number 5. Perfect. Alrighty, number 5. See, Glenn wants to improve his grade in history after failing an exam. He decides to study an extra 2 hours before his next exam, and his grade improves by 9%. What is the unit rate for this situation? Yeah. So back when we were writing rates last semester, I told you money always goes on top and time should always go on bottom. So if he's studying for 2 hours, 2 hours is time, right? So that 2 hours is going to go on bottom. And his grade improved by 9%. So let me double check the answer key. I just want to make sure that the 9% we can leave as a whole number. Yes. So his grade improved by 9%, right? So if I want to know how much his grade would improve if he studied for 1 hour, I would divide top and bottom by 2. So if I have 9 divided by 2, what decimal would that get me? Remember, 9 divided by 2. We're dividing here. The 4.5, perfect. Which means that for every 1 hour of studying, his grade improved by 4.5%, which would be our unit rate. So 4.5. All right, and then let me know when we're ready to go on to the next one. Hi, Tyler. So right now we're going over checkpoint 8. If you want to join us. Okay. Did you need help with the different assignment, or did you just come in to say hi? Okay, perfect. All right. So let's see. Next problem here is talking about a party planner. And it says a party planner uses strings of lights to decorate a patio. He buys a box of 8 strings, and the box indicates that the string have 720 light bulbs total. What is the unit rate for this situation? Use your answer from part A to write an equation for L to throw light, or the total number of light bulbs in a box with S strings. Okay, so for part A, we want to know the unit rate. So how many total boxes does he buy of string? How many total boxes does he buy here? Buys 8, perfect. And how many light bulbs are in all 8 of those boxes? 720, perfect. Yeah. So to figure out how many light bulbs there are per string, whoops, this is string, not boxes. I don't know where I got boxes from. I would divide top and bottom by 8. So 720 divided by 8 tells us how many light bulbs. 90, perfect. So that means that there are 90. So 90 light bulbs for every 1 string. So there are 90 light bulbs for every 1 string. And for part 2, the equation. So we know what our unit rate is. Our unit rate is 90 over 1, right? So which one of those equations is the only one that has 90 as the number? Which one would it be? Remember, our unit rate is 90, so we're looking for an equation that has 90 as the number for my K. Perfect. There we go. So L equals 90S. Perfect. Next one. So a grocery store sells 4 1/5 pounds of shrimp for $29.19. What is the unit rate for this situation? Select the answer that is completely correct. Okay. Well, whenever we're writing a ratio and we have money, money always goes where? On top or on bottom? Where does money always go? Money always goes on top. Perfect. So I'm going to put this 29.19 on top, and I can buy 4 1/5 pounds of shrimp. So for a unit rate, I need a 1 on the bottom, right? So I'm going to divide top and bottom by my denominator. So I'm going to divide this by 4 1/5. Then let's type this into Desmos. So I have 29.19 divided by 4 1/5, which tells me that it is $6.95 for 1 pound of shrimp. Okay, so now let's look at our answer choices. So let's see, this first one says that the unit rate is the amount of shrimp sold per dollar. $1 buys 6.95 pounds of shrimp. Well, that's not true because it's $6.95 per 1 pound. So we want to pick this one that says the unit rate is the price per pound. 1 pound of shrimp cost $6.95. All right. Next one. Right. A home insurance company gains 10,000 new clients who file 380 insurance claims throughout the year. The following year, the company gains 40,000 new clients who file 1,520 insurance claims. Is the number of new clients proportional to the number of claims? Why or why not? So since this question is asking, is the number proportional? What we need to do is create a ratio for both of these and see if they're equal to each other. So remember, when you're writing your ratios, your total is going to go on bottom. So out of a total of 10,000 clients, 380 file an insurance claim. And for my next ratio, there's now 40,000 clients and 1,520 file an insurance claim. So now let's type in both of those into our Desmos to see if we get the same number. And if we get the same number, then yes, they are proportional. Make sure I add the right amount of zeros. All right, so when I divide both of these out, I get 0.038. So are these decimals that I get the same? Yes, exactly. So since they're the same, are they proportional? Perfect. So these are proportional. So now we just have to figure out which one of these is correct. So that says is not proportional. So it looks like we're looking at these top two here. The number of new clients is proportional to the number of claims because the ratio of claims for the first year is equal to the ratio of claims from the second year. Okay, I see here. So this second fraction, notice how this fraction's upside down, right? So it can't be that one. So we want to pick this one here that has both of our ratios correct. So make sure that your larger number is in the denominator and saying that it is proportional. All right, number 9. A movie theater calculates its revenue using the equation R equals 4.8 T, where R is revenue in dollars and T is the number of tickets sold. Okay, so R is revenue in dollars and T is the number of tickets. And our equation is R equals 4.85 T. What is the revenue if 88 tickets are sold? So we're talking about 88 tickets, right? So do I want to put 88 in for T or R? We're talking about 88 tickets. Do I substitute that for R or T? T, right? Because T is the number of tickets. So where T is, I'm going to replace it with 88. So like Chelsea said, what we're going to do here is multiply. So this right here is what we're going to multiply. 4.85 times 88, whoops, which tells us how much total revenue did the company bring in. Perfect. Awesome, you did get it right. And so make sure that you choose your answer carefully because notice how this one down here has that 0.8. Make sure that we pick the one that has 80. So $426.80. Perfect. All right. The next one. Consider the following equation where D is distance in miles and T is time in minutes. So we have D equals 23.7 over 48T. Which scenario does the equation describe? Okay, so D is distance and T is time in minutes. Let's see. So remember, when you have, whoops, let me have a pen. We're at 23.7 over 48. Remember I told you guys that your bottom number is always going to be time. Okay, so it's however you can measure time. So T is time in minutes, which means 48 is minutes, which means that the top has to be distance in miles. And you can kind of think about it like if you're driving on a freeway, it's always like 60 miles per hour. So it should be miles per and then hour, but here it's minutes. So this is telling me that if I have to drive 23.7 miles, it's going to take me 48 minutes. Let's see. So this looks like it should be this bottom one here. A commuter spends 48 minutes traveling 23.7 miles. All these other ones have the units in weird places. So it should be this very bottom one. So the commuter spends 48 minutes traveling 23.7 miles. All right. Are we okay to go to the next one? All right, perfect. Number 11. So a research assistant is paid $10.75 an hour to assist with data collection. What is the independent variable? Okay. So it looks like this is how much she's paid hourly. So $10.75 is how much she gets every hour. The amount of money that she makes depends on how long she works, right? The longer you work, the more money you're going to get. So the independent variable here is how much you make per hour, because this number will never change, and it doesn't matter however many hours you make, it's still going to be $10.75. So our independent variable here is going to be the amount paid per hour. So A is the amount paid per hour, and dependent would be the number of hours that you work. Wait, let me double check that. Sometimes when I do these, my brain thinks about it backwards. Yeah, okay. I was thinking about it backwards. So let's see, dependent, independent. Okay. So independent means regardless of what happens, this doesn't change. So if I work 2 hours, nothing can affect time, right? Time is always going to be constantly moving. Nothing can stop it or pause it or make it go faster or make it go slower. So my independent variable here is going to be the number of hours worked. And then the dependent variable is the total amount paid. Because the amount you are paid is dependent on the number of hours worked. So sorry, for this one here, it should be the number of hours worked. Let's see. And then for B, Chelsea thinks that it should be 7 hours worked and you earn $75.25. So that is correct. So for B, if the researcher works 7 hours, they will earn $75.25. All right. 12. An apple picker harvests 84 apples from 3 trees in an orchard. He wants to estimate the total number of apples harvested from the entire orchard. Assuming the relationship is proportional, how can you write an equation to describe the relationship between T, the number of trees in the orchard, and A, the number of apples harvested? Select all that apply. Let's see. So let's look at these different equations here. Let's look at this proportional one. So A is the number of apples that are harvested, and T is the number of trees. So based off of these two numbers, how many apples was I able to harvest from 3 trees? 84, right? So does this proportion that we have here match this proportion from our answer choices? Yes. So this proportion here is one of the correct ones. We want to pick this one here. And it looks like for this problem, they don't actually have you find the unit rate because this 84 and 3 is used for all the answer choices. So this is going to be our ratio. Okay, this 84 over 3, which means that we are looking at either this equation with t equals 84 over 3a, or this one that has a equals 84 over 3t. So these are our other two answer choices for this problem. So now our job is to figure out which variable goes where. Remember, a is always going to be your total. So the question he's asking is he wants to estimate the total number of apples harvested, right? So if I want to know the total number of apples, if my total will always go by itself, do I want the A or T to be isolated? Which one am I trying to find the total for? Total number of apples or trees? Total number of apples, right? So I want A to be by itself, which means the two equations I'm picking for this problem would be A equals 84 over 3t, and then this top one here, whoops, that A over t equals 84 over 3. Next one. A television station runs 2 advertisements, A, for every 1/4 of an hour of programming. Which answer correctly explains how to calculate the number of advertisements that will run with a 3 3/4 program hour? Oh geez, these answer choices just look really not fun. It'd be much easier if they just asked you for the answer. All right. So I think our first step here is going to be to figure out the unit rate. I think that's our best bet. So there's 2 advertisements for every 1/4 of an hour, right? So if I want to know how many total advertisements there's going to be for 1 hour, I'm going to divide top and bottom by 1/4. So I have 2 divided by 1/4. Tells me 8. So that means that there are going to be 8 ads for every 1 hour of TV. Okay. So that tells me that these two answer choices with this 1/8, these two are out because my unit rate is 8, not 1/8. See, so it looks like the next part is figuring out how to solve the next part. So it says which answer correctly explains how to calculate the number of advertisements. So advertisements is our A, correct? So if I'm using A equals 8p, I know that my program is running for 3 3/4 of an hour, right? Which means that 3 3/4 is going to be plugged in for p, because that is how long my program is. So to figure out how many advertisements, I would have 8 times 3 3/4. So it looks like I want to pick this one here. So the one that says A equals 8p, and then where we have 8 times 3 3/4. So this one here. So that was a lot that happened relatively quickly. Do you guys have questions on that, or do you want me to re-go through it, or are we okay? Good. All right. Hi, Naira. So just so that you know, we're almost done with checkpoint 8. After this question, we have 2 more, and then I'll be putting this recording in the course. Okay. 14. All right, let's see. A chef prepares a large bowl of salad dressing. He adds 3.9 cups of vinegar for every 7.8 cups of olive oil. Which statement best describes the relationship V? Let V be the cups of vinegar and L be the cups of olive oil. Okay, it looks like we need to find a unit rate to figure out which one of these equations is correct. So when we're finding a unit rate, since we're talking about cups of vinegar and cups of oil, I think it's best to just write this in the order that it's given to us. So I'm going to do 3.9 over 7.8. So 3.9 cups of vinegar for every 7.8 cups of olive oil. Let's figure out how many cups of vinegar I need for every 1 cup of olive oil. Let's see. 3.9 divided by 7.8 gives me 0.5. So I need 0.5 cups of vinegar for every 1 cup of olive oil. So that tells me I'm looking at these bottom 2 equations because I have that V equals 0.5, right? Do I want to pick the answer choice that has which coordinate pair is correct for my unit rate here? Which one do I want to pick? This 1, 2 or the 1, 0.5? Which one is related to my unit rates? The 1, 0.5, perfect. So this is the answer we want to pick for A. So that's the unit rate with the 1, 0.5 and V equals 0.5 L. Okay. So part B says how many cups of olive oil are in a salad dressing containing 9.8 cups of vinegar? So I'm going to rewrite our equation here. So I have V equals 0.5 L. Okay. So V is vinegar, L is cups of olive oil. And it says it contains 9.8 cups of vinegar. So am I plugging in 0 or 9.6 in for V for cups of vinegar or L cups of olive oil? Which variable goes with my 9.6? Is it V or L? Remember, it says that it contains 9.6 cups of vinegar. So which one do I want to plug then for? The V, perfect. So 9.6 is going to go in place of V. So I'm going to have 9.6 equals 0.5 L. Now to solve for L here, I need to get L by itself, right? So the opposite of multiplying L by 0.5 would be dividing. And what number am I dividing by? What number am I trying to get rid of? What number do I not want next to my L? The 0.5, right? I'm trying to get rid of this 0.5 because I want L by itself. So I'm going to divide by 0.5. Remember to do that on both sides. So this will go away. And I just need to type this into my calculator. So 9.6 divided by 0.5, which gives me 19.2. So he will use 19.2 cups of olive oil. All right. Next one is 15. Let's see. This one says that Tana opens a savings account and deposits money in the account every month. Examine the following equation where S is the balance of her savings account and M is time in months. Okay, so it gives us this equation here. Part A says which statement is true about the equation given? Let's see, part A. So after 5 months, she saved $552.50. So it looks like we need to figure out, all these questions are talking about 5 months, right? So let's use that equation and figure out how much money she actually saves after 5 months of having money in her account. So M is time in months, right? And if I want to know how much money she has after 5 months, am I going to replace 5 with S or with M? Remember, it's 5 months. S is her balance and M is number of months. So M, perfect. So I'm going to take 5 and put it in place of M. So 110.5 times 5. We can plug that into our calculator. And that tells me that she would have $552.50. See, so it looks like after 5 months, she saved $552.50. Questions on how we got A? Are we okay to go on to B? All right, so for B, we're going to use the same equation, but now we're given a different number. So S equals 110.5 M. B wants to know how long will it take Tana to save $1,215.50, right? So if this is how much money she has saved, I'm going to put this big number in for S. So I'm going to have 12.15 equals 110.5 M. To solve for M, right, the opposite of multiplication is division. So I'm going to divide both sides by 110.5. So if I type this in, it tells me that it will take her 11 months. So part B here is 11 months. So Chelsea, you did this differently, which also works. So since you guys are given the answer choices here, right, I have 10, 11, 12, and then 120 months. I know that every month, Tana saves $110.50, right? So I can take these answer choices and multiply it by this to see if I get this 1250. All right. Bye, Chelsea. Thanks for coming in. We finished just in time. Okay, but for this one, after 5 months, she saves 552.50, and then part B is going to be 11 months.